Alright, so let's talk about subprograms. So subprograms are used to clean up the program. They're used for looping. They are a means to keep organized. So there are two main codes for this, simple codes. It's going to be M97 and M98. Okay? And these codes, in particular, are used to send the cursor of the program, I guess you could say, or to go read something. So M97 on the Haas specifically is local subs, and M98 is going to be non-local. Okay, and M97s means that the sub-program is in the main program. It's below the percent sign. M98 on the Haas is used to send it to read a program in the program list in the controller. So you'd be looking for a program number. So in these two lines of code, you're going to have values of P and L. The P value can be a line number or a program number, depending on which of these codes you use. The L number is loops or repeats. Okay? So when using these two, we are going to stick with M97 for now, mainly because when you delete your program, you still have your, you don't have to load multiple programs into the controller. You have one, and that's enough for now. It gets you the idea. M98 is very useful if you own the machine or you have the machine and you have a main program and you want to call up different variables or call up different lines of code more accurately, or different little programs, different whole locations that are in different separate programs on the machine. So if you're in production, it's ideal. But we're going to focus on M97. Okay? So we'll talk about the local, non-local subs, and then we'll get into basic variables. So I'm going to pause here. We'll get back into Discriminator. I have a simple program loaded to show you, and I'll show you with and without subroutines and what they're all about, and then we'll continue from there. Alright, so this is a program for the drawing file on Blackboard. And it's just a simple bowl hole circle, pretty simple part. And you'll notice that we have our spot drill and drill. And we have all the different hole locations all separate. Okay? Pretty standard program. You should be able to do this by now. This next example here, alright, is a little different. You'll see the G81 and then you'll see the M97 P1000. You'll see a G83, M97 P1000. Okay, what does that mean? That means that we only have to type in our hole locations once. There's our G80, move back to first hole position, M99 back to program. So it saves you a ton of time if you're doing depth of cuts, if you are doing the same hole pattern over and over again, or you could use M98 and you could do different hole patterns that are called out by different programs. And this could be a separate program. Instead of a local sub, you could go to a different program and re-access that information. So you can move in and out of these programs pretty readily. You'll see that we have our, our first hole location, and we have our can cycle call, and then it says go to local sub on line 1000, P1000. That'll automatically go to after the M30, okay, line 1000, N1000. Then it starts drilling the holes. Cancels can cycle, moves back to first hole location. M99 will go back to the next line. Alright, tool change, all that kind of stuff. Go to drill the holes. You're already at your first hole location because of you ended here. Then you go to M97 and it loops these again. So that's what a subroutine does, okay? So it's definitely helpful, definitely saves a lot of time. And again, you could, end up going right to local, which is what I want you to do for this example. Or we can go in and do non-local and actually write a separate program, and instead of an N1000 or looking for a line number, it's going to be looking for, by default, a program, but there is a setting value for that in the Haas controller. All right. Now, one other code I wanted to bring up, and this will lead into our little intro to variables. I'm not going to get crazy in this macro B programming, but there's also a G65, and G65 would be very similar to either M97 or M98, except for if you want to pass variables with it. So let's say you wanted to say, okay, I want to pass along, let's say this program, the G81 was in this cycle, and you wanted to pass an R value, a Z value, or some other values of even a feed rate to the subprogram to run. You could use what's called G65, which is very similar, except for it allows you to pass information from the main program to a subprogram. Okay, so those are the three ways to bounce around. M99 is also useful for bouncing around. Again, for us, it's just going to be loop back to main program for now. All right, so that's basic subprograms. Right. We'll pause here. We'll go back to the whiteboard. We'll talk about our quick variable programs and what these certain variables, and you can do a little equations. And I'm not going to get too into detail on this for this one. I want to get the subprograms down. And I want to just do a little bit on variables, local variables. That's all we're going to focus on. And so we'll go back to the whiteboard, and then we'll come back and look at the next program in Discriminator. All right, let's talk about a little bit about variables. There's different types of variables that you can have. All right, we're going to focus on local variables. Okay, and those are 1 through 33, and these are used to pass information around a program, and it's real simple to do it this way. I mean, I guess it can get complicated depending on what arguments you have in there, and there's if-then statements and things like that, but I'm not going to worry about that for now. We're just going to learn a little bit about working with variables for this first one. There's also global variables. And those are very useful. They remain on when the power is turned off. They are not independent to a program. There's also system variables. And a lot of this you'll see when we start using the Renishaw probing system. You'll see these kind of called out, and I'll explain them as we go. And if we get into editing probing cycles, we'll work with that. The issue with some of these, especially, you can't just edit certain variables in the machine. That's why I usually, when learning, stick with just the local variables or macro call arguments, because the other variables, if you start changing things, some specific values in the machine, and for whatever reason, there should be some settings on there that allow you not to edit them. But if you do, and it's for a probing macro or a probing cycle, you can cause major issues. So we're going to stick with the local variables, okay? Now the local variables 1 through 33 also have a little chart. You could Google this, or you can look on page 224 in one of the Haas milling manuals that are available in the shop. And you'll see, the variables are listed, 1, 2, 3, and you'll also see a letter that corresponds with it. So A, B, C. And it doesn't keep on going through the alphabet necessarily. Like 10 doesn't necessarily have a value. It's all kind of picky that way. So you have to look on that chart. That chart, at least in the newer Haas manuals, is on page 224. And that'll help you. Now, we're not going to worry about the letters for right now. We're just going to focus on passing variables in the program and what that's all about. So, again, basically, you can have a variable like number 1 equals 10, okay? And then you could actually pass that to, use that variable 10 in equations. Number 1 plus number 2 equals number 3. Okay, and then use number 3 to solve another equation, and these would be in square brackets. Okay, so you could do a lot here. All right, but just trying to keep this simple. What I have set up is just a simple speeds and feeds type header on this little macro program I have. And I just want you to mess around with this. So, again, this is very useful, but it's very, very specific. So the only time that a lot of people now are working with this that I have seen is when they're automating their probing systems, automating perhaps the Mitaco shuttle system, or even a little bit of robotics. They'll use different variables, different macro type programs. If they're in production and they have part families, and those families are very similar, but they all the whole locations or sizes change based on certain variable inputs, it's very useful there. So there is a reason to kind of just start with this, and you'll see the power of it when we go over to Discriminator, and it's almost endless. You can do all sorts of math equations in it. You could do a lot. So let's go over and look at the program, and then we can look at it in the simulator, and you can see what it's going to do, what the goal is, and hopefully that'll just give you a little information on the extreme basics of what variables are all about. So I'll pause here, and we'll go back to Discriminator. We'll talk about the program, and then we'll go into the simulator. Alright, so this is a quick little macro program just for an example, and all this is just automating your speeds and feeds, giving inputs. So I had these values in no particular order. So number 4 equals the cutting speed, number 5 equals the feed per tooth, number 6 is the cutter diameter, number 7 is the number of flutes, and then number 1 and number 2 is the RPM, and that would be, number 2 would be the feed rate. Okay? So up on top here, you can just plug these variables in. There's your quick little formulas, I guess you could say. And then in the program, your S is just variable 1, and your feed rate is just variable 2. Okay? And that's what this is all about. And again, you could have statements like, if number 1 is less than number 3, or less than 5, or whatever it is, you could put your your math equations into the program. And there's also statements like while this, then this, and etc. So I just want to show you a little bit about this without getting too crazy. Just the basics on what variables are for this one. So let's pan right over, and I'll load up the, we'll take a look at the simulator for this program, and I'll show you in the lower left corner over at the controller in the main spindle box what actually happens in this program and what we can change and how this works. Alright, so you see our macro program loaded here. One thing I want to point out is to get the calculator down here, or the main spindle tab, to read the proper chip load and surface footage, you need to make sure in your offset page that your diameter and number of flutes is accurate. Otherwise, again, it'll kick out the right RPM and feed rate, but it will not be correct for chip load and surface footage. So now if I go to run this program, I'll run it in single block, and we're going to be looking for a 500 cutting speed and a 5 thou chip load. So we'll get down into here, and you'll see there's variable 500 feet per minute surface feed, and then we go to variable 2, 5 thou inches per tooth. Okay, so it does the math for you. All right. So now let's try changing something. Okay, so we'll go down here into edit, and we'll change the cutting speed to, let's say, 200. Okay, we'll alter that, and we'll change our feed rate, let's say, to, let's say, I don't know, 0.00, let's say something slow, well, let's say 1/10. Okay, there's that. All right, we'll hit memory, program, and reset, and you'll see we're looking for a 200 surface footage at a 1 thou inches per tooth. Again, we're not changing other variables, which would work, but just remember, if you change 6 and 7, you got to make sure you change it in the offsets. So I'll single block through this, and we'll see that we go down into the RPM, and we get a surface footage of 200, and you go to the feed rate, you get 1/10. Okay, so it's just adding a little bit of equations and different variables into your program. All of your math could be up here, and your program can be a little bit simpler. You're not typing in as much, things like that. And this is a very simple example. Okay, you could put examples where if you just type in aluminum, it could calculate something. Or if you type in A, and A equals cutting speed of 200, which is variable whatever, and it gets kind of crazy. And again, you could use these variables with a G65 and some letters if you wanted to, and pass variables from this main program to a subprogram. So there's a lot of things you could do here. Again, I want to try to keep this as basic as possible. You'll work with us a little bit for this assignment, and we'll go from there. So hopefully this was a little different, a little interesting. There's a lot to this. Some people use this a lot, some people don't. I've seen some very, very elaborate macro style, variable style programs that are pages and pages long and spreadsheets worth of variables, and they're very impressive. The biggest instance I've used this is whenever I'm doing indexing. So if I have a program that cuts something and I need to index it 47 times around a diameter, okay, and I need to pass variables, or if I don't, I'll just use subprograms. Either way, it's a lot of times I do this, it's for the same feature over and over again around a diameter, let's say, or the same feature but could have variables for that same feature given different part numbers that I want to pass to a subprogram. So this is really a production thing. If you're in production making a lot of parts that are very similar, or you have, sometimes you have, different hole drilling cycles for different types of situations, depth of holes, things like that, you can give the machine and tell the machine exactly what you want it to do. All right. So again, hopefully that was interesting, and let me know if you have any questions. Thanks for watching.